Well, good morning, ladies and gentlemen. Today we are having a very quick look. Actually, it's an incredibly long look. This video is an hour and 40 minutes. If you don't survive it, I don't blame you. I'm not going to watch it. It's mostly a slideshow. I helped someone, SuperNick, who you may have seen in the intro, with trying to get this machine up and running. Unfortunately, my lack of knowledge combined with his lack of knowledge resulted in twice the lack of knowledge we were expecting. Now, it's not all bad. He did actually win the RetroChallenge for the Australian, the ACMS, Australian Computer Museum Society, I want to say. They're a group who are local here in Sydney, and they are a museum for computers. So they actually put up some prizes, and SuperNick actually won. I did a bit of GeoCities stuff. I won last year, so that was cool. GeoCities is pretty fun. I wish I could talk for an hour and 40 minutes about GeoCities. I probably could. But this is Nix, or SuperNick's video. So, the Dasher 386. It is huge. It has been neglected. Look at that. Look at those ISIS slots. Look at that back to front one. That's proprietary. Would you believe it? Intel 386, amazing. I think it was clocked at 25 megahertz. Jeez. Just incredible. Look at that. The power supply is not even installed properly. Anyway, the first prize was a microscope, which could actually be used to potentially do some trace repair on this machine. Now, if SuperNick had won the microscope before doing the RetroChallenge, it might have been a bit more of a success. Unfortunately, that wasn't the case because time is linear, and he's won the microscope now. But as you can see, we've got a slideshow here. We've been going for 3 minutes. These photos are essentially just documentation so that people remember that the Dasher 386 did exist. It wasn't a fever dream. It was real. Those RAM slots on that motherboard, I remember that. They were bad. Like, the clips were snapped, but brittle plastic after, I mean, this machine, I think we worked out it was early 90s. Given we're 2022, 2023, that's, you know, geez, that's 30 years. Okay, yeah, that's fair. That said, we took the motherboard out. Each photo displays for 10 seconds. I accidentally upped that from 4 seconds on a previous video. As a result, yeah, that's sort of the reason it ended up so long. So it's my bad. It's a nice looking. Look at that motherboard though. That is a nice motherboard. It is big. It's got 4 chips, 4 socketed chips. That what do you call that RAM? The standing upright RAM. That's the video RAM for the onboard video chip. There's just something about 90s technology. The Sega Saturn. This board actually did remind me quite a bit of the Sophia, the Sega Saturn Sophia development kit. The size of the board, trace wires almost everywhere. Little resistor packs. But as you can see, the condition of the board was not great to begin with. We were actually working on a theory at the beginning that, what was it, the power good PG, orange line coming from the power supply, was not giving the signal to say that everything's okay, you've got good voltage, engage the power, turn on the CPU. That was our working theory. I think that was after we tried replacing a few capacitors on the main board. This being similar age and era to the Sega Saturn Sophia, there were a couple of 100 UF capacitors that looked a little bit suspect. There's some of the dip chips. Those have 3 of the 4 of those have been dumped. One of them I couldn't work out how to actually dump the chip, which was unfortunate. Now it sits in a cupboard. This G2 chip. You've also got the chips chip and that chip there. Those chips actually form the chipset, which I found very exciting. Actually, SuperNick looked into it. I'll just call him Nick from now on, it's just easier. Nick looked into it and he found that it was a particular chipset, except one of the chips didn't quite match what we found. I think it was the ALSA logic chip. The G2 chip and the other chip were okay. What's that? Is that there was a cache chip. Yes, that looks like it. So it's got a fancy cache chip to make things go fast. But yeah, we had quite a lot of sort of corrosion on that board. Serial number. We did a what was it? It was a baking soda and vinegar. There's no way I'm going to be able to talk for an hour and 40 minutes. That's a pipe dream. I'll put classical music at the end. It won't require any sort of effort on my behalf. There were some dip switches. We have no idea what they were. Kind of have a feeling it was something to do with the ports at the back, controlling speeds and whatnot. No coprocessor installed, which was a bit disappointing. What were those chips? Those were the onboard memory? Question mark. It's been a while. This was October that we did this. Those are definitely microchips. Yep, certainly a lot of microchips. They seem to have a lot of these yellow, not necessarily yellow stickers, but stickers that look like they are a specific part number, like what IBM tends to do. At least that's all I've had. God, that board was in terrible condition. We did think that it might have been stored at a beach in the open, but we couldn't confirm it. I don't actually know how SuperNick came across this. But he thought it was appropriate for the Retro Challenge. I just... So the problem is with hardware, you either succeed or you fail. The good thing is with the project I picked, which I'm going to talk about a little bit, GeoCities, is that I succeeded to a degree. And I didn't win a damn microscope, that's for sure. Yeah, that's fine. I don't need a microscope. What do I... He said I can use the microscope if I do the voiceover, so... I just got to keep voicing over. What else? So there's the board. So this should be a 4K video. So those photos should be relatively close to the original resolution. There's the chipset of those 3 major QFP chips. They're very big. The socketed chips one was like the BIOS, the video BIOS, and I think one of them was split over 2 chips. Probably for cost-saving reasons or speed reasons. Don't ask me. I've never used a Data General, which I probably should have mentioned earlier. This is a Data General Dasher 386-25, I think. But as you can see... Oh, it also came with a VGA card. An ISA VGA card. Or ISA. And it was rusty. Like, it was actually rusted. Maximum RAM on this board, I think they were 1 meg DIMMs max. So you could have a total of 8 meg, and then the expansion card in that proprietary slot we spoke about earlier, the one that's a reversed ISA slot, could double that to 16 megabytes. So you could really go crazy with your expanded memory there. You've also got the hard drive connector. There you go, there it is, just in the middle. I think that's the hard drive connector. Yes, because that's the floppy drive connector up the top there to the left, which did the... what was it? It was the floppy drive. Yes, the floppy drive. We were also missing all the mounts to actually mount the hard drive and floppy drive in the machine, so that posed another problem. The amount of hurdles were numerous. A lot of crystals. Whoa, okay, where's everything gone? That's just the chassis. As you can see, it looks like it's been at the beach. It looks like it went out and... Okay, we're back to the board. There's the board again. That's a nice... It actually looks kind of nice. They picked a nice forest green, so it doesn't really suit the beach theme. Are these in any order? What order have I added these in? There's more micro... Oh, the sockets were empty. Yeah, okay. Oh, we were probably just trying to get detail of each of the chips. Because the next step that we did involved cleaning... I've got air quotes. Cleaning the main board or motherboard with bicarbonate soda. So pretty much sprinkle it over the board and then add a ton of vinegar. Now, we had some problems because for some reason there was a shortage of... Well, there were 3 steps. You need the bicarb. There's the bicarb. Oh yes, we had plenty of bicarb. Don't worry about that. The bucket we had wasn't big enough, so that caused problems. But man, that leopard print carpet tile. Oh, jeez. Fizzy good make feel nice. You drop the vinegar on top of it, everything becomes magic, shiny, new. It's great. Unfortunately, any leftover reagent, if you know chemistry and you do your balances, I didn't balance the equation properly. We had a lot of leftover stuff, which we just washed off with more vinegar, but we couldn't get much vinegar from the shops because they were out of vinegar and stayed out of vinegar. I don't know what happened. So I think we ended up using cooking vinegar toward the end instead of cleaning vinegar. Vinegar's vinegar. The strength changes. I don't know which one's stronger, to be honest, but this is all just guesswork. We don't know what we're doing. We have no idea. Anyway, it fizzed so nice. It is the most satisfying sound. It took me back to moments when we were children, skipping through the backyard with bicarbonate soda and vinegar and adding them together and having it go fizz. And then mother yelling from the balcony going, "You stupid kids, I wish you'd never been born," only to have to live the next 60 or so years. So then we sprinkled it this way, the bicarb soda, because we didn't get sort of all the ports along the back because of the size of the box. As you can see, the precipitate down the bottom in the actual vinegar is unreacted, or it's reacted to form the precipitate, which is bad. Yeah, there was too much. Who does these animations? Why am I so good at this? So we couldn't get distilled water or demineralized water. So we managed to find the most dirtiest sink we could, and we filled it up with just plain old tap water. My God, it looked clean. But this is the reason we took so many photos beforehand, because we were worried that the labels would be destroyed in the process. A lot of them actually survived quite well. That looks amazing. But then we only had one bottle of demineralized water, so we had to do our best. So we dried the board as best we could, and then we put it into this demineralized water. And it was just a shallow bath, and we just rock it back and forth like a baby, I think. Put the baby in the water, rock back and forth. I might have some of those things wrong. I'm not a parent, don't worry. And you end up with a board that's potentially better than it was. But then the trick was to let it dry. No, it was the inspection of the cleaned board. I wonder if this is after it dried. That area was horrible. But look at that. I didn't really believe in this process before I tried it. I've heard of other people doing it. But we'd never really done it. So SuperNick was a bit apprehensive about this. It's like, are you sure this is what we should be doing? And I said, look, the machine doesn't work. The worst case is it stays broken. Best case, something happens or the board looks really nice. And it's more photogenic than me. That is actually quite beautiful. All those areas there cleaned up, magnificent. But that corrosive layer that was sitting on top had actually done damage. I'll touch on that a bit more in a little bit. There are those 100. Those are not 100. Oh, there they are. 100 UF. Yes, there was a mix. 100 UF and 10 UF. And a couple of tantalums. Thankfully, nothing caught fire, which I was actually surprised at. I was expecting to get... I didn't get zapped. Neither of us got zapped. Neither of us got shocked. Look at that closer inspection. If you zoom in on that, you will actually see those traces have little black parts on them. So the mask is coming away. At least that's what we've been told. Now, whether that's good or bad, it's obviously bad, is yet to be determined. I don't know if it is actually at a stage where it's affecting the conductivity between points. I seem to keep going between these two images for some reason. I don't know why. Okay, we'll look inside the power supply. Never mind, the motherboard's it's drying. So this is the power supply. It's a, I believe it was a Delta power supply. Okay, pretty standard power supply stuff. SuperNick said that he did not want to really deal with AC stuff, and quite frankly, I agree. Malfunctioning AC stuff in particular can be very dangerous if you're not a professional, and we're not. But look at that. You can see that diode question mark is green. And even on those cables, like that the brown and the blue, they're your neutral and live. That's not good. Over here we have, this is sort of the 5 volt, 12 volt side of the power supply. On the left, okay, that clicks by too quick. Those are big capacitors. We didn't replace them. There's Dale, named for his rugged good looks and resisting 1.2 kilo ohms. But it looks like, as far as we could tell, look at that, that's just horrible. Like there are crystals growing on. It's just, yeah. We had turned it on at this point, and we were getting no, post wasn't completing. But look at that. That's the lid of the power supply. Something got in there. I suspect when it was stored on the open beach that a seagull went into the fan, and it was a windy day with lots of salty air. Ouch. Well, that actually timed quite well. So, of course, in the name of preservation, let's preserve something. We've got these chips. These are still available. If you jump onto the ACMS forums and look for Dasher 386, you'll actually find a link to where you can download these. I think they've been archived on archive.org as well. DGC is Data General Computers, I'm guessing. Looks like it was using some sort of Phoenix BIOS from the ashes and then back into the ashes, unfortunately. Yes, that's definitely another microchip. You'll notice the numbers change. Really? I took photos of the under... Wait, I didn't take the... Nick, why did you take photos of the underside of the chips? No one cares. Maybe someone cares. If anyone out there is still listening at this point, do you really care that we took photos of the underside of the chips? We're 25 minutes in, an hour 44. Award software? Oh, that's right. One of them's... We've got the video BIOS in here as well, don't we? Yeah. So at this point, this was the chip that I couldn't get a read on because it's actually got a little, I think it's got a microprocessor in there or some RAM or something that prevents me from dumping it with the readers I have. I'm not overly concerned. Whatever computer code is on there is probably still on there. But these chips are getting quite old. The good news is their windows weren't exposed, but that doesn't stop bits from flipping over the years. And the longer you have a chip, the more likely that is to happen. And there's all four of them. Oh, there's a different angle. Looks nice. Looks very nice. It's very photogenic. Much like that motherboard earlier. No, that's the one we couldn't dump. The D8742. Had to destructively remove the stickers to get that one. But yeah, it looks like it's a chip that's sort of a combo chip. We had a look at the data sheet and then we dumped everything like this. Using it was a Mini Pro TL866 or 866TL. I can't remember one way or the other. Oh, there's the okay, it's gone. What was this? This was searching through the Mini Pro database to try and see if there was anything that sort of matched. That said 4.1. We did 4.2 as well. Don't worry. Oh, that's the web address of where you can actually get the dumped BIOS. And if you can do anything with it, that'd be cool. Here's a capacitor that we didn't like the looks of. Its proximity to RAM and processor made us think, ooh, let's go ahead and replace this. Now, the board itself was actually quite... Oh, that's all the capacitors. 29 on the main board. Yikes. It's a lot of capacitors. So look at that again. So it doesn't look like there's many. Yeah, no worries. No worries. It's easy. There's none there. Oh my gosh, there's 29. Yeah, a lot of them are just 10UF. There was a 47, a couple of hundreds near the power supply connector in the middle of the board. Fun fact, the power supply connector is non-standard AT, which just made things a little more fun. We made a list. So we've got the power supply capacitors and the mainboard capacitors listed there, as well as a fan, battery solution. Keyboard pinout potentials. We didn't actually know what sort of keyboard this uses, which is another big problem. If you don't know what keyboard you're using and you get it to post, what are you doing? You can't do anything with it. You'll see there 4 capacitors have been removed. The one on the right is the replacement. The one on the left is the original. We could actually go for the slightly taller capacitors, as long as you were careful with putting the board in and out of the chassis. There weren't any problems. Which also allowed us to upgrade voltages on some of them. Yeah, it does look good though. Look at those, very nice. We did find that the copper plane, because it's a multi-layer board, sort of needed a lot of heat from our desolder gun, and we might have slipped a couple of times if you look at those scratches on the board. But yeah, let's look at the first power on attempt. So we actually get power. That's a hard drive, and it's got this strange hard drive connector at the front for the LED. I've never come across that. I don't generally deal with PCs of this age. But we still had no post. Now, we did have a floppy drive in there that came with it. That actually had its mounts, but it also looked heavily corroded. So we thought maybe it's the VGA. The VGA card might have been in there because the onboard video was dead. But instead we checked the voltages and found that the 5-volt rail from the power supply was only providing about 4.4 volts. 12-volt rail was providing 12. Okay, so no problem there, except that the 5-volt rail is a little on the low side. We then went and checked with a known working power supply and found that we had 5.1 on the 5-volt and 11.5 on the 12. So our next picture was to do with the keyboard. There's the keyboard hole. I hope it increases the exposure. No? Okay, we're going to this one. I've put these out of order. Keyboards are extremely screwy. Look at the differences in the angles between these. It's horrible. One of them is like an Ethernet port. Ah, there we go. There's the increased brightness. So it did actually fit a typical XT-AT5 pinned in. Whether that would have worked, whether the extra pins were just there for additional keys allowing a backward compatibility with a connector like this, which is also corroded. I don't know what it is with corrosion and old computers. It fit physically. Our next step would be to check electrically where things were going, but we never got to that stage. Mainly because the machine didn't work. So we looked, because the voltages, you see, why did I put the keyboard there? Because the voltages were a bit iffy, we thought, okay, so see that orange cable in the middle of the screen? We thought, maybe that's not sending the right thing. And it looks like that's probably controlled by those two little circuit boards that you can now see to the very front right of the screen. Those guys right there, closest to us. We suspect that they generate the signal that goes down the power good connector, power good pin, and says everything's fine. But looking in this power supply, nothing's fine. I'm actually surprised it didn't catch fire when we turned it on. The fact that we didn't break the motherboard, though, was definitely something to write home about. Or rather, didn't break it more. But yeah, look at all that corrosion. So that corrosion's coming right along there. But it looks like it also came in through the fan. So came through the fan and like splattered to the... Yeah, those blades so would have splattered to the left if you're looking at the fan. So because the 5-volt rail wasn't quite living up to expectations, we thought, okay, let's start there. Let's go ahead and let's replace all the capacitors on the low voltage side. We're not going to touch the high voltage side stuff. I think there was a 330 UF that might have bridged between the two. We replaced that because we could. We learnt a little bit about capacitors. Ripple. Having high ripple is bad, generally. Low ripple is good. ESR, these sorts of terms. And these BP capacitors, bipolar or non-polar caps, which are generally replaced by MLCCs, which are multi-layer ceramic capacitors these days. Funnily enough, back in the day, they probably would have used ceramic capacitors, but the problem is that they get too big. You can see that big orange one down the bottom left. But we even had corrosion inside these plastic sheaths around these resistors here. Now what was really annoying is that most of the cables were socketed, but not all. The ones in the middle were not. So we had to work with the cable connected, which made removing the power supply PCB very annoying. From memory, the capacitors were Sanyo, I think. And we replaced them with either FR Panasonic series, Panasonic FR series, or Rubicon. What were they? You know what? There's going to be a picture of them later on. I know I added that in. What was it? L. Something L. The power ones. They're good for power. I've got the little chart sitting above my desk, so I remember. We'll come back to it. We'll work it out. But yeah, the AC line, the fact that it has sort of evidence of splatter, of salty looking water on the cables, doesn't bode well for what was underneath. So it's turning on. The question is, for how much longer would it turn on? So we're going to try and fix it as best we can. Now, don't like AC things. I've never died personally from working with AC. The closest thing I've done is cut through a live kettle cord with a pocket knife. Don't ask why. I don't know why. I'm a little bit blank on why I did that. But let me tell you, the pocket knife, it was never going to peel an orange again. It was important to get the routing of where everything went here, because honestly it was a bit of a rat's nest. There's the switch. So the AC actually just flows straight into the switch. Which, yeah, that didn't make me feel very safe. Especially in a power supply that's been water damaged. That's the switch, all right. So we removed the. So you have to. The switch had to be removed to get the board out. So to remove the board from this power supply, you had to disconnect the fan. The fan was hardwired. Oh, it's a Delta fan. Which is really annoying. And then there's all these bolts and screws and things. And half of them go to the main board. On the power supply. Power supply main board. So you take off some bolts, you take note of which bolts you've taken off and where they go. Okay, that's definitely there. And alakazam. The washer is there. Don't forget that. Remember that one for later. You don't have to. I'm just messing with you. I remembered, or Nick remembered. One of us remembered. Point is, none of us got electrocuted, which was nice. So I think with that one removed, there were then only the four screws holding down the power supply to the thing. So we've still got the fan hardwired. We've got the, I think it was the floppy drive and the Molex connectors essentially I mean, they're all Molex connectors, aren't they? The Molex connectors for the hard drive and floppy drive that were hardwired. The main board, 5 volt, red right there, and black ground were socketed. So I don't know why they made that design decision, but there must have been a reason, right? Yeah, so that's really just about to come out. I'm just taking photos. Oh, okay. All right. It looks like we're switching to looking. I mean, there were screws. You have to take my word for it. There's the underside of the PCB. It looks pretty innocent. Or does it? Let's get a CSI enhance. Nope, apparently not. It's just a different angle. Down the bottom there and toward the middle and on the top left, there's actually a bit of corrosion. It's all on the DC side though. The AC side was actually clean. I'm guessing that's why it didn't catch fire yet. Emphasis on yet. That's just more of the same. There's a close-up of the middle of the DC side. Those pins that are corroded and facing down are capacitors. And these ones here, ooh, they're not good. They're not in a good way. You've got ground on the right. Yep, it's gone, never mind. And then I think 12 or 5 on the next two. But as you can see, there's heavy corrosion. It's not going to be good. Whether they're actually creating shorts in the circuit, like the smash hit movie with Johnny Five, he was alive. Yeah, I don't know. Interestingly, whatever chemical reaction had happened, we're not at the stage yet, but there's one of those boards that I reckon control fancy stuff to do with the power good. It monitors sort of the power supply rails. There's the orange cable again. That's the one that we were sort of hypothesizing was our problem. This corrosion opened a whole new can of worms though. So anyway, we looked at these boards first. So we thought, okay, let's take some photos of these boards. Then what did we do? We're in a plastic tub, so we're probably going to clean something. Now that the power supply board is out, and these two little daughter boards are still attached, we're going to try and do as much as we can, because we don't want to have to put it back in and take it back out, because that's extremely annoying. Remembering the Retro Challenge runs for 30 days, has September, April, June, and November. All the rest of 31. Remembering October has 31 days. We had 31 days to make this work, as best as we could. I honestly think the Retro Challenge, and not the Australian Computer Museum Society Retro Challenge, but the Retro Challenge as a whole, cleaning corrosion, should be 2 months. Or maybe 3 months, maybe a quarter. By the time they sort of assess everything that's happened, like from start to finish, it takes them a year. Like the actual RetroChallenge.org people, I don't actually know their website, but it's on the internet, don't worry. So we actually went and used, this is another thing we'd never really tried. This was, we used CLR. Calcium, lime scale, and rust, at the recommendation of a more seasoned technician. And it worked to a degree. I don't know if I bought the spray bottle might have been the wrong one. I should have maybe got the tub. Is there a tub? I don't know. All I could find was a spray one. Anyway, as you can see right here, I've completely covered that in. Actually, it wasn't me, it was Nick. I got to watch. And it was only after we did that... Where's the photo of the bottle? Have these been washed with CLA yet? I don't know. There was corrosion on these boards and a bit of pitting. Sort of that black spots in the mask, which could have been causing issues. I think at this point we're just trying to get all the values of the capacitors so we can replace them. That's why we were recording this, that makes sense. We didn't touch any of the ceramics, we only messed around with the electrolytics. One of the electrolytics we couldn't actually get, so we had to get ceramic, multi-MLCC. Even the silk screen had a picture of a MLCC. There's one of the daughter boards on the power supply. And the back. So this one had a little bit of pitting at the top left and bottom right, but nothing too severe. This is the other board. This is the one that was further back in the power supply. It was much worse, especially on that bottom left-hand corner. But even that trace sort of running along the top is sort of a bit iffy. Yeah. And funnily enough, we did trace where these pins actually went, and one of them, or at least one of them, went to the power good pin, the orange cable from the power supply, which made us think, okay, maybe our hypothesis is sound. It looks like we've got flash on for these, which it's exciting. That's CLR, so that's actually submersed in CLR. Now the capacitor would be replaced, so I'm not too worried about the electrolytics. So it was removed and then sprayed with, I can't remember what its name is. It'll come to me. I don't know if there's a photo of it. It's like a WD-40, but it's non-conductive. That's going to bug me. I also can't catch fire, which was nice. But it was greasy, it displaces water. It's probably something really bad for you. There's the original capacitor. There's the capacitor we're replacing it with. We're using a YXF Rubicon because we had it on hand. Wouldn't matter too much for this. It's probably a filtering cap. I say that. It's probably the most important capacitor in the whole machine. What was it? We sprayed it with... I didn't like the looks of that ceramic capacitor. It looks like it actually soaked up a bit of the corrosion. This is pre-CLR on this one. We did them one by one just in case the CLR completely destroyed the first board, and then, you know, we'd walk away. Oh, this is post-CLR. That's a new capacitor over there. Oh, maybe this is the one we recapped and then we... It's been too long. What is it now? February. Febbers. This was October. It's nearly 6 months. Manufacture date of 2025, so... week 25 in 2020. A good week. This is the other board that we haven't replaced any capacitors on. Oh, maybe that was showing the final product. Oh, we replaced a capacitor. You're saying we. I was there. I got to sort of watch. We didn't have the other two capacitors at this point, so there was not much else we could do. And this ceramic capacitor, its value sort of disappeared. We tried shifting the contrast and a whole bunch of other things, but we didn't know what it was, so we sort of just left it and hoped it wouldn't catch on fire. Unfortunately for anyone who is recapping one of these power supplies, I don't know why you would. Really, just use a newer power supply and an adapter. It's a much better way to do it. But it's important to note that hot glue as well, where that is, because that actually rests against the second board. So the third capacitor that doesn't have any, I think we just bent out of the way. But the other two were bit more difficult. But there, the one closest to us is the one that was replaced with a ceramic 0.47 UF. Yeah, barely anything. Fun thing I learned though. I don't really deal with capacitors that go both ways, but the non-polar caps are essentially just two capacitors with their polarities in the opposite direction joined together. And that's how you make it. It's actually that simple. Who worked that out? Let's remove old capacitors and visual inspection instead. Oh, this is from the power supply. Oh, this is kind of exciting. So there goes a capacitor. Look at that though. That was one of the bigger caps. Oh, they're Nichicon. They're Nichicon. They're not Sanyo. They're Nichicon. They were very difficult to remove from the center of that DC area. Yeah, whatever the chemical reaction was that causes it to go that black pretty much stopped us from desoldering. We did eventually get them out, but my gosh, it was way more difficult than it had to be. There's a close-up of that. I mean, somehow, and I don't know how, those traces were okay. They shouldn't be. They certainly don't look like they should be. Now, whether they need reinforcement because there's too much resistance, that's another question. As we'd find later, that would be the least of our problems. But it's a nice, simple two-layer board, one-layer board. So it was nice to work on, except for all that corrosion in that area. Capacitors that were toward the top of the board on the DC side, you can quite clearly see the division there. I mean, on this side you can't really see it anymore because, I mean, there's the AC side of the capacitors. They're sitting there, they're massive. But here's where all the other ones came out. They all had a little bit of leakage to some degree, which is sort of to be expected at this time. I mean, that's a long time. That's way beyond their rated life. Now, if they'd used Rubicons... yeah, just some more photos showing off the chips that are in there. So these two boards were cleaned and left dry. the fan was the next thing of... We sort of said, well, look, if we've got it out, let's replace it. And then we made this, which told us the capacitors, which we've already seen on a previous slide, but... So these are the original capacitors we were going to replace them with. Note the size differences. These are what we had on hand. The only thing we didn't have on hand was the 6800 UF. Now immediately you can see some of those capacitors that we're replacing are twice as big. And that's where ripple current comes in, and ESR. It turns out that capacitors vibrate. And when they vibrate, they create heat. Or something. I don't know. I'm not a physicist. Electrical engineering is not my thing. Which is why... Well, actually, it's not Nick's thing either. In fact, why are any of us working on this? Look at that transistor. That's an old transistor. The that's where the fan came out of. Desoldered. Take that fan. We cleaned up a lot of the corrosion that was present, at least the superficial stuff. There's Dale again. Howdy, Dale. It actually ended up looking okay. Except for these guys. We thought, we'll leave these guys till a bit later. We'll try and clean them out, but it's going to be tough. That's more power supply. Just a different view, I suppose. So for this board, we then go with isopropyl alcohol and just clean off as much as we could, essentially, to make it nice, just to avoid any little bits of metal flakes that might have come loose, while documenting all the transistors and doodads, I want to say, inside. That chip there at the front had some issues. It was quite a cheap replacement, but we forgot to add it to the order. It was a bit corroded on some of the legs. Quite corroded. Cleaned most of it off. But we do wonder if it's something as simple as that. The manufacture date on some of these things though, look at that, 91/16, so week 1691. Where were you in 1991? Geez, I was in primary school. Wow. What's this one? Did we clean? We did clean those two big resistors with the corrosion. We desoldered them, took their values, which we'll probably come across a bit later. These, I want to say rectifying diodes, maybe? I don't know, they're on that side, so... I don't understand power supplies. That's generally if I've got a 5 volt source and a 12 volt source, maybe a 3.3. I'm happy. You throw 240 at me? I don't know what I'm doing. No one knows what they're doing. I didn't want to... If you're still listening at this point, we're an hour in. Nick actually cried when it didn't turn on the first time. Like, I have never seen someone so devastated at such a garbage computer. Now, I don't want to say it's a garbage computer, but I just did. This thing can't run Doom properly. Or maybe it can. I can't. Was it Doom? I can't remember. That's a Stargate, I think. Yeah, Jafar, Cree, all that on the other side. $91.17 date stamp, 91.15. So, yeah, the manufacture dates. This was quite early in, or at least this power supply was manufactured quite early in 91. I think the first probably quarter. 52, 26, second quarter. Just. So it's like April. Yeah, there's another component. It's looking very componenty. I hope someone finds this of use in the future if you do happen upon one of these. I can't wait for Nick to let me use that microscope, though. This has been the longest voiceover ever. We're at 1 hour, still 40 minutes to go. We might talk about the microscope. So the microscope, it's like a camera, but it's a microscope. So it looks at small things. I'm going to try and find things in the natural world, not so much electronics. And I've actually, I don't know if anyone's noticed, but I've got a sister channel called Super Nature World. So you put an @ symbol and Super Nature World, and it's just me recording pictures, videos of cicadas or cicadas, depending on where you're from, and lizards. It's quite a good channel. It's very peaceful, except for the cicadas, which are in most of the videos. Oh, there's millipedes. Yeah, they're quite small though. Which is why the microscope would be so good. There's many reasons to get that microscope for doing this voiceover. Oh, this is still going. It's upside down. What have I done? What have we done? Damn first person. VGA connector. What? I should not have started talking about the microscope. Okay. They're probably the mounting screws for the onboard VGA connector. Yes, they are. Excellent. So the kind of washer goes in the middle, which isn't really surprising. Such excitement. Dasher 386-25K. Yeah, okay. Model number. Okay, back to the power supply. That was weird. That is literally the opposite of a power supply. That is a power supply hole. Oh my god. So some of this mask was damaged. This is the AC side. So we went over some of the solder with some fresh solder. Reflowed, if you will. We did try to reflow as much as we could on this side, but some of these were just not needing to be done. The top half was pretty good. This is sort of the middle of the board. You can see that divide between AC and DC. It's a nice, solid divide. Probably designed by someone who knew what they were doing. To be found 30 years and worked on by 2 people who didn't know what they were doing. So the AC side did have some corrosion, but it looked much better. Yeah, it definitely, the DC side definitely had it worse. Which sort of begs the question, how did it get into the DC side when it clearly went in on the AC side? It must have just been the whole thing of it being on a beach. I guess maybe you shouldn't really put computers in the sand on a beach. Actually, there wasn't much sand. There's some organization of, I'm guessing, the outer screws. Not quite sure what these ones are. Maybe they're more VGA ones. Oh boy, that looks oily. So that's been sprayed with the non-conductive water displacement. If I could remember the name of it, I'd say it. Now, being a petrochemical, it sort of went everywhere. And we do sort of wonder if it might have made its way up into the transformers, which, from what we understand, it's not conductive. So it's non-polar, I guess. Being an oil. Yeah. Hard drive? That's what I ask myself. We actually found a hard drive that looked like it might have been from the right era. And from this machine, maybe, potentially. And it had no bad blocks. We were quite surprised. We ran it through bad blocks in Ubuntu. So we realized that if we did get the machine powering on, and then 107 meg, that's a big hard drive. If we got it powered on and found a working keyboard, we'd need something to boot to, I guess. The floppy drive looked like it had as much corrosion as the power supply, so we weren't hedging our bets on that. And of course it had a proprietary connector, I think. I'd have to check that one. So over the next week or so, I think it was quite a period. We went through and desoldered the 10 kilo ohm resistors. Actually, we cleaned these up. We got the corrosion out of them. Because we were waiting on capacitors. We went through and we ordered capacitors that had higher ripple current, high ESR values. Look at how much nicer that looks. Jeez. Oh, that looks amazing. Oh, technology. Yeah, we were waiting on the capacitors, which I think had to come from the States because there's a capacitor shortage, chip shortage at the time, of course. Made things very, very difficult to time. But both those resistors were the same, so we popped them back in. And everything was looking good. Much good. Until... Dun, dun, dun. We measured some other resistors. Gosh, that's boring. I was kind of hoping something fun would come up. 25 motherboard capacitors. So we hadn't finished with the motherboard capacitors. We must have ordered them, I guess. Or we just figured, let's do them. Let's replace it. So that one looks like it's bulging slightly. They don't have vents on the top either, so... There's a lot of capacitors though. I remember looking over and going, "You done those capacitors yet, Nick?" And he'd look back at me with this face of anger. Like he was angry at me for there being so many capacitors. I didn't put them there. Blame Data General. As you can see, it was quite simple to know when the capacitors were replaced because they doubled in height. It actually slides into the chassis, so you have to be very careful not to snap them off accidentally. And these RAM slots, we weren't sure. Not these RAM slots. We sort of had a look around for replacements potentially, but we didn't sort of come across anything that would be any better. There's all the old capacitors. My gosh, do not envy Nick for that. And I think these are just the ISA slot. Yeah, most of them had to be reflowed before you'd desolder. Very fun. We also found some little bead tantalums hiding on the back. Just making sure everything is ready to catch fire, because that's generally what tantalums do. I like my electrolytics. It's not my fault. Yep, that's definitely... Yep, they're capacitors. Let's move on. And there's the board again. So that probably has all the capacitors replaced. It does, yeah. And we triple checked they were in the right way. We actually we found one of the chips, socketed chips. Thankfully, before we tried turning it on this time, or the first time, was in back to front, and that one is actually on me. So, yeah. I'm pretty sure the chip's chip was the VGA, onboard VGA. Can't remember what that one was. I mean, it says 133, so it's probably something to do with some sort of bus. That's the CPU. I know what that is. Don't even joke. That sure is a thing. Looks like they do something with the other thing. WDC. Now these were chips much similar to the that had the word proto on them. They were the same as Sophia again. So Sega Saturn Sophia. No, Terra Drive. Jeez, wow, that takes me back. The old Sega Terra Drive. Actually, they both had a ton of trace wires on them. There's the cache that made things fast, apparently. But looking at the back of the machine, since this is where the power supply would have been just sitting above, you've got that corrosion. So it either sat in water and was turned on or something. I don't know. It's the keyboard connector for the 20th time because you can never get enough of it. Okay, so now the motherboard capacitors. So these are the replacements. ZL. See, we've got a YXG for the 16 volt 6800 because you couldn't get anything else. Height wasn't a problem. That third capacitor along there, the ZL, actually had two spacings. So you could have either a, I think it was a 3.5 millimeter spacing or a 5 millimeter. So I went 5 millimeter. ZL's basically what you want, or what I wanted, or what Nick wanted, what I told Nick to get. Was it overkill? Maybe. But as you can see, the capacitors are all the same size or bigger, which means given that we don't know the original specifications of the original capacitors, honestly, inserting a... what could you insert? Like a toothbrush in place of the old capacitors would probably work better than the old capacitors, just due to how old they were and the fact that half of them were leaking, or most of them were leaking. As you can see, the one on the end there has turned into an MLCC, which was quite different. And there it is installed. Actually, it looked quite nice. I asked if I could have that board and he said no. So I took lots of photos of it. So MLCCs are non-polar as well, so that works well for everyone involved. But look at the markings on the board. That was not designed for a radial. At least originally. They must have subbed it in. Shortage. So there it is with all the capacitors installed as far as I can tell. Yep. So there's 3 biggies there. That's I think that was a 330 UF. But as you can see, height was no issue, so we could order capacitors as tall as we wanted. That's why that 6800 ended up bumping from 10 volt to 16 volt. No issue, which also increased the ripple and all that jazz. YXG, yeah. Usually I use the YXG or the Y series stuff for the lower values, but for some reason, yeah. Oh, this happened. The hot glue's gone. It fell off because of the petroleum-based electro-resistant super glue, whatever it was. Which unfortunately meant that we would have to use the hot glue gun, and we are not very good at the hot glue gun. So there's the fuse. This is over back on the AC side. Yeah, I don't really like using the hot glue gun. It's a bit dangerous. Nick didn't seem to mind. He used to, no one's going to hear it at this point, but he's going to, he often enters line dancing. He's got sequined boots, so he often uses a hot glue gun for that. No judgment. I mean, if he wants to do that sort of thing, that's fine. Oh God, what are we up to? 1 hour 20 almost. Anyway, Shania Twain was playing a lot while he was using that hot glue gun, because traditionally, when it comes to line dancing and you're putting sequins on your line dancing boots, oh, look at that job, that is horrible. You are using the hot glue gun while listening to Shania Twain, because she, of course, is the best country and or Western singer that this world has ever known. The hot glue also helps to stop, I'm guessing, vibrations. Those capacitors are quite big because they shake? I don't know. Is that a ripple current thing? Someone can correct me in the comments if they've managed to listen this long. Yeah, not replacing those two at the very, on the AC side, they're expensive. No, it was outside the budget. Mick said, look, let's not do them. And I was like, okay. They're big and can zap us as well. So this looks to be the reinstallation of the daughter boards onto the motherboard. And there's the second one. I think it was at this point we realized that we didn't quite leave enough wobble to sort of bend that capacitor electrolytic on the lower board. Yeah. Whereas these ones used hot glue, which was cheating because we didn't want to use hot glue. I think we did. Let's flick back. See, one's tilted out of the way, no problem. What was the solution? Is that hot glue? Yeah, it is. Yeah, we used hot glue. It's like they say in the industry. Near enough is good enough unless it's on fire. At this stage it wasn't on fire because there's no way for it to sort of catch on fire. There's no voltage going in. But as you can see, that's pretty much back in one piece. At least the boards and the capacitors. So everything that we could replace, except for one opto coupler, I think, was replaced. And that's slightly closer. I feel like that's a duplicate photo. Why would you have two like that? Same photo. It did look good though. After we sort of left the WD-40 knockoff, I'm going to remember its name as soon as this video ends. It's in a can. It's got a little nozzle thing and a straw you can like plug into the nozzle, which is just like WD-40, but it's not WD-40. It's got a 2 in the name. Here we go, getting it back into the case. So we actually scrubbed down the casing with a wire brush. You can't really see it that much on the fan grill there though. It looks quite rusty. Just to get rid of any flakes because we didn't want any immediate shorts. I generally only wear shorts on the weekend. Oh, that was a horrible joke. Can you even consider that a joke at this point? Then we had to go back to our photos, which weren't terribly good, and remember how all this went back together. At this point you can see the big screw on the power supply, so the power supply is screwed in. Switch went back in the off mode, and we just needed to add one more thing down the bottom there, maybe? Nope, I don't know what changed. Something did. But we were feeling mildly confident that something would happen. Visually confirming those capacitors were bad. I mean, 30 years old, okay. Yeah. Probably bad. Gave us a bit of a confidence boost and a bit of a second wind. We were sort of giving up when we didn't get power the first time. We thought it would be something easy. It wasn't something easy. So the fan went back in and had silly bolt wrench things, hex nuts. Everything got plugged back in. Threaded out. Fan cable was routed. We made sure that nothing was sort of shorting that shouldn't be shorted. This is sort of last glance inside the power supply before we say goodbye, because we really didn't want to take this apart again. We really didn't want to take this apart again. And everything sort of looked okay. Visually, anyway. Electrically, well... I think there's actually some video in this footage. It's not just stills, but yeah, there sure are a lot of components. Look at that. You can see the non-standard AT connector up the top. It's gone. Still a bit of grease on the board. We did clean up as much as we could with Q-tip, cotton bud Q-tips. Any excess anyway. But we sort of feel that a fair bit might have soaked up into some of the components it shouldn't have. It said non-conductive, but we're sort of having second thoughts. But we thought, okay, look, if it catches fire, we've got a fire blanket, we've got a fire extinguisher for electronic things. We know where the power point is, we can stop that, we can smother the fire, everything will be fine. Very rarely everything is fine. But that's what it looked like in the end. We had it back in one piece and, you know, it looked sort of like it did originally. So we hooked it in. We're testing the 5-volt rail first off. Power supply. That was a typo. I'm not going to correct that. That's fine. That can just slide. And we powered it on at the switch. So this is at the wall. The power supply is already turned on. So when we turned it on for the first time, at the wall, so it's quick at it, we were very surprised to see that we were getting 4.95, but it was fluctuating a bit. Typically these sorts of things should stabilize. Now we're in auto mode, so we're not to a decimal point. That should also be noted. The fan wasn't spinning correctly. It was actually making a clicking noise as if it was trying to turn on. So we went and had a look at the 12-volt rail. And my God, it's all over the place. You can see the fan trying to start up. But we've actually activated what's known as the crowbar circuit, or a crowbar circuit. I don't understand power supplies enough to talk in detail about this, but I'll say that it's generally not good. But then it made it sort of question, how do we go from having a working 12-volt rail and a broken 5-volt rail to a working 5-volt rail and a broken 12-volt rail? Well, the answer's simple. We broke it even more, but in a different way. So now we're turning it on with load. We've got a hard drive connected, and we've set the decimal point to static. So you can see it's switching. This is the 12-volt rail, switching between 6 and 2 volts. So it's never making it to 12. It's shorting and there's the 5-volt rail. Similar thing again. But when it's in auto mode, it smooths it out, apparently. So we went and checked the voltage of the battery. I feel like this one is way out of... It shouldn't be where it is. But that's the date, time, BIOS settings, battery clock thing, I guess. That's what it had. Look at the date stamp on there. 1990, November. This is our replacement using good old AA batteries. And Velcro, which they used first, to be fair. So we've got 1.2 times 4, which gives us 1 times 4.8. We found some Velcro dots, which was cool. We didn't have to pay for them. We stole them. Don't tell anyone. It sort of stuck down. This is not very exciting. Oh, back to the power supply. Part 42A. What? So we're testing the 5 volt, or at least that's what's in here. Why is this a still? And that's the 12 volt? I kind of feel like these should be... Ah, this is measuring the resistance. We were trying to get an idea of the... This was actually before we discovered the crowbar was crowbarring, because we were on auto mode. We were under the impression that the 12 volt rail had problems and the 5 volt rail was perfect. Again, a seasoned computer technician helped us. More like an electronics wizard helped us work out that it was crowbarring. That's the term. So we tried comparing with known working versus the original power supply, but when it comes to measuring resistances, yeah, that's not going to work. So it sort of begs the question, why were we doing it? But I thought I'd put it in here anyway, just to say, we're idiots? What's this one? Yeah, screw it. We'll use another power supply then. So Nick sort of said, well, what if this fails? And I said, well, okay, let's have a look and let's get an ATX to AT power supply adapter-y thing. Now, the beautiful thing is on the right there, we've got the this one, which is the Data General bastardized AT power connector. And the good news is that we were able to remove each of those cables and poke in the replacements from the one that actually had the AT connector to ATX. Now the ATX, one important thing that it had to have was the light blue and white cables, which signify negative voltages of 5 and 12. I don't know in which order, you'll have to look that one up, but Sky Blue, that was the name Nick gave it with a smile, because he was like, well, that one's not blue, that's Sky Blue. And I said, Nick, you are such... It was fine, it had been a long day at that point. But as you can see, we've got a lot of voltage rails there. We've got the ground, 5 volt ground, 5 volt ground, 5 volt ground, 5 volt ground, 5 volt. Sky Blue, yeah, there we go. So orange is the signal. We destroyed the adapter, ATX connectors. The original Data General connector is mint condition. So yeah, we didn't... It took a while and a lot of stabbing. Interestingly, no one got hurt. But the original stayed okay. So as far as preservation goes, I guess that's a tick. Maybe. And because all the lines join up for the red and blacks, it doesn't really matter. We weren't putting too much load on it. they all join up and had continuity with each other. So we did it this way. Now the green and the black cable that you see at the front there, we just tied them together because I think we actually soldered them together. That's the power switch. What did we do? Maybe we just taped them together. It's a long time ago. Should have done this voiceover a long time ago. Why am I doing the voice? I want the microscope. I want to use the microscope. Yeah, okay, fair. Oh, it's a bulldog clip. We used a bulldog clip to hold them together. Okay, so here's the setup with the known working ATX power supply. Bastardized and actual video. And made into whatever the horrible non-standard connector was that Data General was using. So we flick it on at the power point and we are measuring the... I can't see where the probes go. Oh, that's nice of me. I think I was doing this recording. So, oh no, it wasn't. No, this wasn't me. This was Nick. I was in charge of the power switch for this one. He didn't want to touch it. Smart man. So 5-volt rail and yeah, cables everywhere. We're using auto mode on the multimeter again and we've got a bit of load because we've added that hard drive in just to make sure we don't blow something up. I don't know. That's a pretty stable 5-volt if I've ever seen one. 4.99? You really gonna do that? But we've got power, which is more than what... Actually, did the power light come on before? I don't actually remember. Doesn't matter. That hard drive is old as time itself. I think that was a faulty drive. I don't know why we plugged that one in instead of the other one. As you can see there, that's pretty stable. So we connected the monitor to the VGA on both the onboard and ISA card, and yeah, well, that slide says it, doesn't it? Beat me to it. But here's bonus extras, so who cares? So we actually failed. The project didn't succeed. God, this machine has had such a hard life. Look at that. How does it even happen? 90s brittle plastic, maybe. So what lessons did we take away? Well, I have to speak for Nick because he's not doing the voiceover. I am. I'm going to say that we learnt that old computers are very big. Their power supplies are not always standard. And it probably wouldn't have played Doom very well. But it could have been something simple like those RAM slots being damaged. It could have been the dip switches needing to be set a particular way. It could have been a few things that were just giving us no post. It could have been that the BIOS chips over time have flipped bits where they needed to be not flipped. But when it comes to the power supply, yeah, that's definitely a whoopsie. Probably shouldn't have done that. I want to say lesson learnt, but knowing Nick, he'll probably do it again. It's a very heavy machine too. I wrote that note and I put that on there so we don't connect it to power accidentally. because that crowbar circuit's not a good thing. Without the schematics, you're probably not going to have a good time. But even then, you'd only be fixing up a faulty power supply to power a machine that just does nothing but no video. Here's an up close of those traces that look like they lost some of their mask. Now, these had continuity as far as we could tell. The question was it enough continuity? Oh, there's a GIF that's flicking between, that's the 5-volt rail. So you can see the red's in the red, black's in the black. This one I've got it it's out of frame, and that was the 12-volt. 12-volt rail with the crowbar circuit. Here's a bit of information on the actual dasher, 386 25K down the bottom there. This is dated July 1990. Feel free to pause and have a look through. It's the small footprint. Yes. And performance. Now, it was actually, apparently, according to this at least, quite good. Especially when it came to video. Then again, this was a long time ago. And yeah, this actually had quite a lot of information about the specs. It is copyrighted material though, so yeah, look out. This gave us a bit of hope when it came to keyboards. Data General had been in business for quite some time. That keyboard sort of looks like the keyboard image on the back of the machine. I've left the web addresses up the top there just in case anyone can use them. Fujitsu Peerless switch. Here's the power supply. So pin P8.1 was power good on the AT. So, yep. It was really fun. When we were researching that, we came across a fair bit of information, all very old information, of course, because AT is a long time ago. Some references to the dip switches, not the particular dip switches, but dip switches on terminal models, which Data General did a lot of. 386s were kind of cool because they weren't terminals. So it could have just been printer port, it could have been communication, it could have been a whole mix of things, we just don't know. And without just randomly changing them, I mean, there's eight switches. Here was some information on power supply that we stole from Hackaday. And then we're back to whatever this is. Keyboard. This has the keyboard noted, or a keyboard with a similar pinout, I think. J12. S-Clock, SI, KVC reset. So some of those we wonder if we did use a 5-pin DIN, if some of those would just be ignored because they weren't used. And we did have a look around for similar RAM slots. I think these were potentially okay, maybe? I don't know. It's been a while. And I don't know what that was. Oh, this is the converter from ATX to ATX 20-pin with negative 5-volt and negative 12. And it was so cheap. It was like $6 Australian, which is like $2 US. So I think that wraps it up. But wow, got through it. That means, Nick, if you're listening to this, you owe me a go of that microscope. And I'd just like to congratulate, on the end of this video, who I consider the real winner of the ACMS, Australian Computer Museum Society, RetroChallenge 2020/10 10. 2022/10. Pendleton 115, if you're out there. That iMac G4. The way you made this for Halloween, it's beautiful. I just want to say that you did a really good job. And I'm sure I speak on behalf of most of the members of ACMS when I say, if a computer is broken and it has no hope of repair, it's best to turn it into a pumpkin looking thing than to... I actually don't know where I was going with this, but very good work, Pendleton 115. Thank you all for watching, if you did watch all the way through. I don't know how you did it. My voice is dying. I'm not going to be able to speak tomorrow. My work colleagues will probably be quite happy. This is Shane McRetro signing out on behalf of SuperNick. We thank you for watching. And now I just need to work out how to stop the voiceover. Classical music!